So, you have 12 square feet of wood available to you. You would like to make 1 foot tall box with the largest volume possible. So you want a box, 1 foot tall. And what is the dimensions of the box? So the surface area, you want the surface area to be 12 square feet. So one of the equations we're dealing with is our surface area is going to be 12 square feet. But what you notice here, it wants the largest volume. So we have to do a volume formula, which is going to be length times width times height. So let's call this length times width times height. What's my height? Did it tell you what the height is?
Yeah, 1.
1. So can I replace height with 1? Are we okay with that? So can I go over here and replace height with 1? Can I put that at 1 right there? So isn't my volume going to be length times width times 1? Or length times width? So I right now made my volume formula because we're maximizing my volume. I just made my volume an easier equation. But the problem here is, this is what I'm trying to maximize. I still need to get rid of either L or W. And I use this 12 square feet somehow to do that. I have to create a secondary equation, solve that secondary equation to replace either L or W. And watch how that happens. My secondary equation is surface area. So surface area is equal to 6 sides. Isn't there a front and a back? Each length times height. So won't the surface area be, the front of it, won't it be 2 length times heights? Plus, well, don't I have sides? Are my sides going to be width times height? Don't I have 2 sides, width times height? Plus, running out of space here. Don't I also have a top, which is length times width? 2 of those. So that doesn't look very good. But can you tell I have a length times height, 2 of those, a width times height, 2 of those, and a length times width, 2 of those. Will all those add up to surface area?
Sure, yeah.
Now, don't we know the height already? Is 1. And don't we know the surface area is 12? So let's replace all those with 12 equals 2 length. Can I get rid of height? Height is 1. Plus 2W, because isn't height 1? Plus 2 length times width. Okay, so that right there is my surface area function with L's and W's. I want to make this so that I can stick it in and replace L or W. I want to make it easier. I think W's are easier than L's. L's look like 1s. So what I'm going to do is I'm going to solve this for L so I can stick it right there and make it all W. So this is all W over here, and we can have a nice clean function. So I need to solve this for L. Could I divide everything by 2? That'd be a good first step. So divide both sides by 2. I have 6 equals L plus W plus LW. Now I want to solve for L. Isn't this kind of like implicits? When you solve for L, can you get L by itself? Remember implicits? Watch this. Can we minus the W over? So that 6 minus W equals L plus LW. And here's what I mean by implicits. Don't you now have to pull a GCF of L out? Remember that? You get L, you used to, implicit got Y prime by itself, pulled the GCF of Y prime out. Here we're getting L by itself. Can I pull an L out, leaving you 1 plus W? And then how do you get L off? I mean L by itself, you divide this off. Now all of that, what is this equal to? L. L is equal to 6 minus W. Can I make that W plus 1 instead of 1 plus W? Is that okay? 1 plus W is the same as W plus 1? Can I go take this and plug it right, where's a good formula? Can I plug it right up here? Watch this. Can I take this, take a little trip, plug it right there, so that I now have a volume formula that's all based on widths. And then I'm going to maximize that. So my volume formula is now, my volume formula is going to be volume equals length times width. And my length is that 6 minus W plus 1. Okay, now we need to find the maximum of this. I'm going to distribute the W on top because I want this to be a cleaner function. So my volume function is now going to be 6W minus W squared over W plus 1. That right there is the function I want to maximize because we're looking for the largest volume. Okay, all that. Now we say to find the max. To find max, you need to find derivatives and critical numbers. So can we take the derivative of this using quotient rule? Here we go. Let's find the derivative, v prime. Quotient rule is we take the derivative of the top, which will be 6 minus 2w times the bottom minus the top times the derivative of the bottom. What's the derivative? Isn't that 1 at the bottom? The derivative of the bottom is 1 all over the bottom squared. Kind of messy. Let's clean it up some. Is there any GCFs to pull out? It looks like there might be, but there aren't. It looked like there were, but there are not. So can I FOIL this one? Yeah. What you'll see here is I'm going to have v prime is equal to, when I FOIL it, I'm going to kind of go out of order because I can kind of see it. This is negative 2w squared. You get a 6w and a negative 2w, so that'll be a 4w. And a positive 6. And then I'm going to distribute the negative because the 1's worthless. Distribute the negative, that becomes this, all over w plus 1 squared. So that right there, again, I FOILed this first part, but I did it in my head. And the second part, I ignored the 1 because 1 times anything. Yeah. So, what do we finally get for v prime? Don't these combine? Negative w squared. Don't those combine? Negative 2w and the plus 6. All over w plus 1 squared. That right there is my derivative. So let's now find our critical numbers of this. To find critical numbers, we set the top equal to 0 and the bottom equal to 0. So we set the top and bottom of my derivative equal to 0. Now, for the top, we get x equals the opposite of negative 2 plus or minus the square, sorry, it doesn't factor if you didn't catch on. That'll be negative 2 squared minus 4 times a times c all over 2 times a. So we're going to have to simplify that down. That kind of stinks. We'll come back to that. Can I come back to that one? What's the other one going to be?
Doesn't matter.
Well, the other one, can you show the other one's going to be negative? Let's do it. But if you do the other one, aren't you going to get w equals negative 1? Because don't you square both sides? Minus the 1 over. And can you have negative 1 width? Can I ignore that one? That's kind of dumb. What's awesome about practical problems like this is you can throw out negatives. Because it makes no sense to have negative measurements. Okay, this one still, let's go back to this guy. That's a little annoying. What I get 24 plus 4, kind of got to squeeze it down here. I'm going to pull this one down here. We have, I put x. Isn't this w?
Yeah.
I messed that up. Okay, w equals, let's see what we get here. 2 plus or minus the square root of 28 over negative 2, which if you divide both by negative 2, w equals negative 1 plus or minus the square root of 7. I might have just screwed some of you up right there. Right there, mess your brain. What I did is divide both by negative 2, and I broke that down to 2 square root 7. That's 2 square root 7. So I got that. I kind of skipped quite a few steps. Sorry. Now the square root of 7, isn't that somewhere around 1 point something? Oh, 2 point something. Is square root of 7 2 point something?
It's about 2 more seconds.
So let's say it's 2.5. What's 1 minus 2.5 and 1 plus 2.5? Well, don't we want to do the plus? Won't the other one be negative if I do the minus? So for my W, won't it be about, let's do a squiggly, 1.5. That's about what my W is. So this answer is an approximate. It's probably more like 1.6, 1.7, but I'm using 1.5 for ease. I need to make sure this is actually a maximum, though. So I'm going to do first derivative test. I'm going to do the first derivative test. I abbreviated that. And what's on, I want to do both sides. So won't that be V prime 1, isn't that on the left? And V prime 2, won't that be on the right? Oh, by the way, why did I not use second derivative test? Because that is ugly for another derivative. This is easier when it's an ugly derivative. And what we're looking for is a max. So I hope it goes up and then down. So when I do this, won't the bottoms always be positive because of the square? Won't the bottoms, because of the square, always be positive? Got it? So now we just kind of focus on the top. When you plug in 1, won't that be 2 small numbers? Isn't that going to be a positive? And then the second one, when I plug in 2, if you look at that carefully, you would notice you get a bigger negative. When you plug in 2, it's going to be negative. Kind of going kind of quick there, sorry. And I did the math in my head. But what I noticed basically is I got a negative here, positive there. So what that means is I'm going up, and then I'm going down. So doesn't that mean it's a max? So this right here, we're on the right track. That right there is my maximum, my width that will produce my maximum volume. So my question is asking for dimensions. So my dimensions are, let's write what we have so far. I'm just going to write it right here. Write it nice. My dimensions are, my width is 1.5 about, by, I'm doing, have you seen this by this by this? Like x is by. Isn't one of them 1? Isn't the height 1? Don't we need my last piece? This is my width, this is my height, I need my length. How do we find that last dimension? Wouldn't this formula be a good one to plug it into? Isn't that a good spot to put it? Now, we're going to use 1.5, even though it's not perfect, but that right there is a goodie. So what I'm going to do is, I'm going to find my length at 1.5. I made it into a function notation. 6 minus 1.5 over 1.5 plus 1, which is 4.5 divided by 2.5. So this would be 1.8. And if that's about 1.8, my last measurement is 1.8. So my 3 dimensions are 1.5, 1, and 1.8. Now remember, this was an approximate, so this is also an approximate, but that's about what it would be for your dimensions, which answers your question to get the largest volume with 12 square feet of wood and 1 foot tall.